Now on to Mdisks. These are the logical constructs that are directly mapped to either the physical disk or VMDKs that have been provisioned for storage to be used by your Actifio appliance. Now, the way that these are created is crucial. We don't put a lot of stricture around how you create them because we understand that everybody has a different use case and maybe has a different goal with their Actifio appliance. However, from a performance standpoint, I'm going to cover some of the really critical configuration items. Mdisk size. Mdisks should never be more than 2 terabytes. When we make a request to the pool for a specific piece of data, we know which Mdisk it lives on. Now, if we've carved out a single 50 terabyte Mdisk to create a dedupe pool from, when we make the query to the Actifio appliance to say, hey, give me this data, it has to search that entire 50 terabyte Mdisk. We know which one it's on, but we still have to search once we get onto the disk level. If we carve these up into 2 terabyte VMDKs, or we give it physical disk and assign it 2 terabyte Mdisks, we will be able to go directly to the disk that it lives on. And now we only have to search through 2 terabytes of data, which is much, much faster than having to scrub through all 50 terabytes from a single 50 terabyte Mdisk. Now, location. The ideal with an unlimited budget would be every pool is consecutive platters on consecutive spindles, all on their own shelf, and every pool gets its own controller. Sounds great, right? I understand nobody, including myself, has the resources to actually set up like this. Really, the take home is try to get the entire pool on the same controller. And it's okay if one controller is managing the storage that hosts both your dedupe, performance, and primary pools. So I've mentioned the primary pool twice, and I haven't told you what it is. The primary pool is the pool where the Actifio operating system lives. You will never be putting data in there or taking it out. That's simply where the software lives. It's a pool that you will see. It's generally, depending on your version, between 1 and 400 gigabytes, but you really don't need to worry about it. That's where our software lives. The ones that we really care about are the performance or snap pool, you'll hear it referred to as both, or the dedupe pool. So ideally, we want the entire snap pool on one shelf. Consecutive spindles would be great, but it's not necessary. So long as the entire pool is on one shelf, the whole snap pool, the whole dedupe pool are on different shelves, but have their own shelf, we should see pretty amazing performance. The opposite end of that is we don't ever want a pool to span storage devices. So you've got 2 NetApps in your data center. That pool, be it the snap or dedupe, should live strictly on one of those 2 appliances. We should never see data moving through the interconnect because a pool is spanning 2 physical appliances. So really keep it on the same shelf if possible, and absolutely keep it under one controller. Performance can take a huge hit if we have to start using the interconnects between the controllers. I also suggest leaving one unassigned Mdisk. So you're going to create all these 2 terabyte Mdisks, or you're going to assign them from your physical storage, and then you're going to assign them out to pools. Now, what I recommend is that you leave 1 or 2 of these Mdisks unassigned. If you ever got into a situation where a recovery was critical, the machine was really busy, your snap pool was pretty full, or you needed to do a restoration of data from dedupe, and we needed the room to rehydrate, but you have 7 or 8 users who have active mounts for production work. We obviously can't interrupt that production work. So what we would do is we would add these, what I will call spare Mdisks, to the snap pool to accommodate the rehydration or to accommodate the additional work that we're doing while the machine is already under heavy load. 1 or 2 disks should be fine. Generally, a total of about 4 terabytes of extra disk is ideal. And I understand that these disks are just 90% of the time going to be sitting there. However, if you do need to do an emergency restoration from dedupe or remote dedupe, and your users have got 15 mounts set up, you will be happy that you've left that 4 terabytes unmanaged so that we can get it into the pool for you and keep you doing business. Now, to get to the Mdisk UI to actually touch all these things that I just talked about, head over to the domain manager, and you'll see the steps here on the bottom left: system, then configuration, and then go into storage pools. From there, you can select either the snapshot or the dedupe tab, and then you'll get the UI screen that I've got pictured on the right-hand side here, which shows the Mdisks that have been assigned, managed, unmanaged, and what your warning and safe thresholds are. So your safe threshold generally is going to sit around 95 to 97, 98%. That is an alert that will be sent to you just before the dedupe pool or the snap pool gets completely full. And the warning is, again, also manually configurable. Generally, it's set between 85 and 95, and that's generally just your early warning. Hey, if you don't do something about some of these images, we're going to fill up and we're not going to be able to accommodate any more snaps. I wouldn't suggest moving those too low. And if you need some guidance, you can always reach out to our support team to discuss the use of your pools historically to see what is the right setting for you. 90% of the time, you can just leave them at the default. However, they are configurable if you did want to use them. Mdisk size and location. Again, Mdisk should be about 2 terabytes, either in a VMDK or 2 terabyte physical disks. Both the physical disk and the data store LUNs need to be ideally, again, on consecutive spindles, consecutive shelves under the same controller. So long as each pool is on its own shelf and it's not crossing controllers, you will be fine. Definitely do not mix the snap pool and dedupe pool. You don't want one spindle to be snap, one spindle to be dedupe. The amount of I/O required, especially for deduplication and operations like GC and sweep, which we will discuss in a bit, are very highly transactional. So when the controller has to jump from spindle to spindle, you will see it impact the performance of all aspects, both snap and dedupe. So any pool that lives under multiple devices, especially during a GC process, is going to suffer immensely on the dedupe side, again, because of the high transactional nature of what a GC is. Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.